Hi guys, welcome to another video. Today we are experimenting with a different concept. Um, so what I have here is a circle, and I have a point or a line that touches the circle at one point. So a line that touches a circle at one point, we call it a tangent. So this point is where it's the point of contact between the tangent and the circle. So that would be my point A. So now what I want to do is I want to form, or I want to construct a chord with the tangent. Here is a chord, so meaning that the tangent and the chord meet at point A, and the chord is, let me label it as label point as B. So here is my tangent and here is my chord. Okay, so now what I want to do, I want to construct or subtend an angle at the circumference of a circle. So meaning that I have to use the chord to form the angle at the circumference. So here's chord AB. Okay, let's label this point also. So here's point C. So what I have here is the tangent and two chords. I have the tangent and the chord AB. I have the tangent and the chord AC. So let me just also include a point here. Okay, show label, show label. Okay, fine. So here is my setting now. I have a tangent and two chords, and the tangent, I can call it DE, forms an angle with chord AB, and that's my small angle there. That's my small angle there. And also it forms an angle, another angle with chord AC. So that's what I have there. I have the tangent DE forming an angle at A with the chord AC and the chord AB. So I'm going to measure the angle formed by the tangent and chord AB. So here's selection. So I'll measure the angle. So this angle here, let me select the angle. Want to select the angle. Let me make it bigger so it's easier to select. Okay, so this angle here, change color, the red angle here. The red angle here is 52.52 degrees. And the next angle I will measure is DAC. Let's measure. And this angle, the gray angle, is 66.02 degrees, and I can shift it here. And I have two other angles which are inside the triangle here. So I have the angle C, which is formed by a B, which is subtended by AB. So if I measure the angle C, it's also equal to 52.57 degrees, and the relationship remains no matter how I move the angles. No matter how I move the angle, this red angle is equal to angle C here. So the two red angles are equal. And let's see if this angle here is equal to angle B. So also we take angle B and measure. Okay, angle B is also equal to the angle CAD, the gray angle here. Let me just change the color. Okay, okay. So meaning now, the gray angle there is equal to the gray angle formed by the tangent and the chord AC is equal to the angle subtended by AC. So what do I mean? I mean the tangent meets the chord AC at A and forms this angle, the highlighted angle, and AC also forms an angle B at the circumference of the circle, and those two angles are equal. Let's see. We've managed to move and reduce C, but angle C stays the same. But when B is reduced, the gray angle at A is also reduced, and when it's increased, the same thing happens at B. So meaning that the angle formed by the tangent and the chord is equal to the angle subtended by the same chord that is forming the angle with the tangent. So the angle formed by the tangent and chord AB is equal to the angle subtended by chord AB. So that is called tan-chord theorem, and we can see that the angles are equal no matter how we move the points on the circle. So on the next video, we are going to explore the proof and see how the relationships exist.